In this video, we will talk about index seek, scans, and lookup. I'll be using database AdventureWorks DW for this demo. I'll be creating a table called table2 for this demo on database AdventureWorks DW. Table2 has got 4 columns. Column 1 integer primary key, column 2 and column 3 is integer again, and column 4 is varchar10. Let's execute that. I'm going to insert close to 5 rows into table 2. Once this is done, what I'm going to do is I'm going to check this particular query, which basically selects column 1 from table 2, and the predicate is column 1 equal to 1. Let's enable the actual execution plan, and then let's execute this query. So it returned value 1. Let's look at the execution plan. We are able to see a clustered index seek on table 2. Let's hover our mouse on the cluster index seek operator. So what I'm able to see here is we have an estimation of 1 row, and then we are returning 1 row. So right now, when I executed this query, I was able to see that we get an cluster index seek on table 2. So let's execute the next query here. If we execute this query, what I'm able to see is I'm getting a cluster index seek on table 2. Estimate is I'm estimating 1 row and returning 1 row. So now what I'm going to do is I'm going to execute this query, which basically selects column 1 from table 2. But this time the predicate is basically not using column 1. Instead, it is using column 2 equal to 1. So let's execute that. And what I'm seeing now is I am getting a cluster index scan instead of a cluster index seek, because last time the predicate was on column 1, and we had this cluster index primary key and cluster index defined on column 1, so we went for an cluster index seek. But this time, since the predicate is on column 2, that is not part of the cluster index, what happened is we had to perform a scan wherein we had to read all the rows and then get back the result. So now what I'm going to do is I'm going to create a supporting index for this particular query. So I'm creating a non-cluster index for this particular query. This non-cluster index ix underscore test will be on column 2 for table 2. Let's execute that. Let's execute the query now. So we have executed it, and let's look at the execution plan. Now, if you look at the execution plan, we are not getting a cluster index scan. Instead, we are getting a non-cluster index seek. Yeah, if you see here, there is an index seek, and this query is using the index that we just created, ix underscore test. Now, what I'm going to do is I'm going to execute this particular query. This particular query is basically selecting column 1 and column 3 from table 2, and the predicate is column 2 is equal to 1. So the non-cluster index is created on column 2. So what I'm understanding is this query will definitely use the non-cluster index. The only problem is we have the column 3 in the select column. So what I understand is utilizing the non-cluster index, we will have to utilize the cluster index also, because column 3 is not as part of the this ix underscore test. So let's execute it, and then let's look at the execution plan. So if I look at the execution plan, what I'm basically seeing is the optimizer did not use the non-cluster index ix underscore test, which was basically created on column 2 for table 2. So it has basically went for a cluster index scan. So now what we'll do is let's force this query to use the non-cluster index ix underscore test, and then see why it actually went for a cluster index scan. So now if you see, what I'm doing is it is same as the previous query. It is basically selecting column 1 and column 3 from table 2, and the predicate is column 2. But what I've done is I have forcefully requested the optimizer to use non-clustered index ix underscore test. That is what I've requested. So let's execute this query. Now, if you look at the execution plan, what I'm able to see is like we have an index seek and then a key lookup. And if you look at the key lookup, it is like 50%. So the optimizer, what it understood is like if we went with this plan, then it would have been more costly. So that's the reason it did not go for an index seek followed by a key lookup. Instead, it went for a cluster index scan. So the optimizer is intelligent enough to understand these variations, and it just comes up with the best recommendation as far as the execution plan is concerned. So now what we'll do is like we'll create a covering index. We will drop and recreate this index. I'm using this drop underscore existing is equal to on. What I'm going to do is like I'm going to create the index on column 2 and I'm going to include column 3. So let's execute this index. It is created now. So let's execute the same query. Now, if you look at the execution plan, now we are no longer going for a non-cluster index seek and key lookup or a cluster index scan. So now we are going for an index seek, and if you look at this, this is the best ever plan that we can have for this particular query. So what we'll do now is like we will create two indexes. The first one is an unique index ix underscore test on column 2 for table 2, and then another query would be an index non-cluster index ix test 1 on column 3 for table 2. So the difference is like the first index is an unique index and the index is getting created on column 2. Second index is a non-cluster index and it's getting created on column 3. So let's execute that. So now what we'll do is like we will look at the index properties. So if you look at it here, ix test and ix test 1 are the indexes that we have created. So ix test is on column 2, which is a non-clustered unique index, and then ix test 1 is a non-cluster index that is created on column 3. Okay, so now if you look at these indexes on the sys indexes system table, what we can see is like the index ID for ix test is 3 and index ID for ix test 1 is 4. Yep, so let's keep that in mind. And now what we'll do is like we will make sure like we are executing each of these queries, and then we will look at the dm underscore db underscore index underscore operational stats dmv, and then we will see if we are performing a singleton lookup count or a range scan count. So we will check that and we will move forward. Let's execute these two queries. This can be considered as the before results because we'll be doing further tests after this. So right now what I'm seeing is like as far as index ID 3, which is your ix underscore test, non-cluster index is an unique non-cluster index on column 2. And then this particular thing is on index ID 4, which is your ix underscore test 1, which is on column 3 for table 2. Yep, so if you look at it right now, the singleton lookup count and the range underscore scan count for both of these indexes are 0. Singleton lookup count, it is the count of single row retrievals from the index or heap. As far as range scan count is concerned, it is the count of range and table scans started on the index or heap. So it is basically like whenever you have a singleton lookup, it basically tells like we are not scanning through a lot of pages and reading a lot of data. But as far as range scan count is concerned, we are reading quite number of data or pages to get the required result. So that's the difference between these two. So what we'll do now is like we will execute this query, and then we will look at the output of dm underscore db underscore index underscore operational stats. Yeah, so what this query is doing, basically we are selecting column 1 from table 2, and the predicate is column 2 is equal to 1. So the predicate is on column 2, so that means like it is supposed to use your ix underscore test a unique non-cluster index. So let's go ahead and run that. We have the execution plan enabled. So if you look at it here, if you look at the execution plan, what we can see is like we have done a non-cluster index seek, and we have used this unique non-cluster index ix underscore test. Now, if we look at the output of a DMDB index operational stats, what we can see is like this particular query that we have used has basically performed a singleton lookup. Yep, that's what it is mentioning, like since it is incremented from 0 to 1. Now what we'll do is like we will execute this query, and this query, what I'm seeing is like we are doing select column 1 from table 2, where the predicate is column 3 is equal to 1. Remember, column 3 we have created the index on ix underscore test 1, and it is not an non-cluster. It is not an unique non-cluster index. It's a normal non-cluster index. So let's execute this query, and we are looking the details of ix test 1 as far as the DMDB index operational stats is concerned. So let's execute it. And what we can see here, as far as this non-cluster index for that is ix underscore test 1 is concerned, this query, if you look at it here, basically like we have used the ix underscore test 1, and if you see here, we just got one record, but we have not done a singleton lookup. Instead, we have done a range scan account, because the problem is like as far as the first query is concerned, we had a non-clustered unique index, and as soon as SQL Server was able to get the first data, it was pretty sure like there will be no more data with the same value because it was a unique index. But as far as the second query is concerned, where we used column 3 is equal to 1, the index created is not unique. So that means like it had to scan through other pages also to understand if there are any other rows with this value. That's the reason we performed a range scan here. So now what we'll do is like we will execute this particular query, which basically is like we are selecting column 1 from table 2, where the predicate is column 2 between 1 and 10. So let's execute it. And if you see here, we have used the index ix underscore test, but we have performed a range scan count here. That's because what is happening is like we had to read through data 1 to 10, so it had to like scan through the entire table to get the information. That's the reason we had to perform a range scan. So now what we'll do is like we will create a table called table 2, and then what we'll do is like we will run other, we'll insert some data and then check further. So let's execute it. We will uncheck the actual execution plan, and then we will insert some data. I'm inserting close to 1,000 rows. This is done. So now what I'm going to do is like I'm going to enable set statistics IO on, and then I'm going to enable actual execution plan. And let's run this query. So what I'm basically doing is like I'm selecting column 1, column 2, and column 3 from table 2. And the predicate is column 1 between 1 and 919. So basically I'm scanning through this particular table and trying to bring in data from 1 to 999. So let's execute it. If you execute this, what I'm able to see is like we have returned close to 999 rows. Let's look at the execution plan. I'm basically doing a cluster index seek. Like we don't have a proper index on column 1, so we are basically we don't have a non-cluster index, so we basically are doing an scan as far as using the cluster index here. So now what I'm seeing is let's look at the statistics here, and if you look at it here, we are basically doing 1,005 logical reads. Okay, so this is the logical reads that we are doing now. What I understand is like we have a cluster index. Since we have a primary key on column 1, we used the cluster index for this particular query because the predicate is basically on column 1. Okay, so now what I'm going to do is like, even though we have a cluster index created on column 1, what I'm going to do is like, I'm going to create a non-cluster index on column 1, and then I'm going to include column 2 and column 3. So let's execute this non-cluster index, and then let's run this query one more time. If I look at the execution plan, what I'm able to see is like I'm basically doing an index seek, and I'm returning close to 999 rows only. So let's look at the message. Now, if I look at the message, what I'm basically seeing is like I'm just doing a logical reads of 5. If you compare here with the previous query, what I'm seeing is like previously I'm doing like 1005 logical reads, but right now I'm just doing 5 logical reads. So I'm like 1000 times better as far as the second query is concerned, and this seems to be a great improvement. But the question is like, why is this non-cluster index is performing very few logical reads, but the cluster index, even though the first query that we executed without this non-cluster index went for a cluster index seek, but still we are not sure like why it performed 1005 logical reads. The reason is like this particular query is basically selecting column 1, column 2, and column 3. Yep. But if you look at the table structure, column 1, column 2, and column 3 are integer, but column 4 and column 5 are varchar max, and it seems like the value that we have is like for column 4 and column 5 is like too huge. For example, if I do a select top 10 star from table 2, if you see here, we have a good amount of data as far as column 4 and column 5 is concerned. Yeah. Now, what is happening is like when we use the cluster index seek, even though this particular query doesn't have column 4 and column 5 in it, if you use the cluster index for any scan, what happens is like it basically has to read through all the data to memory, and then you will basically have to return the data. Even though you are not using column 4 and column 5 in this query, but the cluster index, if you're using the cluster index to seek through the table, it basically reads all the related records as far as column 4 and column 5 is also concerned. And that's the reason we performed close to 1005 logical reads. So what I did is like, since I know like column 4 and column 5 is a very costly column, at least for this query. So what I did is like I created a non-cluster index, and this non-cluster index will only read pages related to column 1, column 2, column 3. And that way, what happened is like I was able to eliminate reading column 4 and column 5, even though those are not required here. So that way I was able to improve the performance. The reason I wanted to show this demo is like there is an understanding that as soon as a column is used in the cluster index, it is not required for us to create a non-cluster index on that. For some corner cases, the like issues like this, for example, if you are getting into a problem as far as the logical reads, and if it is going for a cluster index scan or seek, then this is something that can really come handy. That's it for this video. Thanks for watching. Have a great day. Jai Hind.